Welcome back to another number talk using visualpatterns.org. This is puzzle number 24. It's a good puzzle because let's find out why it's a good puzzle. You can see how it's growing. And when you begin, remember the X is the iteration number in my table. The Y is the number of orange, in this case, squares. So we can count to start. In the first iteration, there are 5 orange squares. In the second one, there are still that 5, but then 2 more. So that's 7. And then now there's that 7, but 2 more. So that's 9. At that point, many students can see that pattern of 2 every time, adding 2 more every time. So in the fourth iteration, it would have to be 11 orange squares because 9 plus 2 is 11. So in the 25th, this is where it gets interesting again. How do you compare the X, the input, with the Y, the output? Well, here is our first iteration, and there are 2 blocks going across. Here's our second iteration. There are 3 going across. Here's our third iteration. There are 4 going across, and so on. So I could see it that way, but that's not the way a lot of students see it. A lot of students actually first see the fact that every single iteration has this 3 squares in it, because that is always happening. We can call the 3 then our constant. And then I have one row of 2. I have a row of 2 here. That's 2 units wide. So this is a row of 2. That's 1 unit wide. This is a row of 3. And there are 2 of them. So here I could probably draw my 3, which is constant. And then here it's going to be 2 rows of 4, right? And that's where 11 comes from. 4 plus 4 plus 3. So that starts to lead into what? It leads into an idea that we're taking the iteration number and we're using it twice. Here the iteration is 3. So third iteration, we have a 3 twice, which could be times 2, and then we're adding 3 at the end, always adding the 3. Over here, we have 2 twice plus 3, and then over here, we have the first iteration, but twice. So it could be the 1 square twice plus 3. Okay, so now we can see that we have an iteration number in the equation. Here's 1, here's 2, here's 3, here are 2 4s. So that technically would be like 2 4s plus 3. So for the 25th iteration, I can picture 2 rows of 25 plus 3, right? I'm going to write it down. I'll write it down here. So 25 twice plus 3. That's 53. So I know there are going to be 53 orange squares in the 25th iteration. So how does that look for any iteration? The X value? Well, I know it's got to be the X, any iteration, twice plus 3. So I write that as 2x plus 3. And that does equal the Y output. So this is the output, this is the input. You do this to it, and then out comes this number. So the equation today is Y equals 2x plus 3. And that is just one way to see it. There is another way that's a really cool way for kids to see a connection. Another way to see this equation is right in here. I could, instead of seeing a constant of 3, some students might see a constant of 1. There's always a rectangle and then 1 more, which makes sense. Now, how can we think about this rectangle? Well, here the iteration is 1, but the length is 2, and there are 2 rows. Here, the iteration is 2, the length is 3, and there are 2 rows. Here again, the length of the rectangle is 1 more than the iteration number, and there are 2 rows. So I'm hoping that maybe you see that 4 is the same thing as like the iteration number plus 1. 3 is the same thing as the iteration number plus 1. And same thing over here. 2 is the iteration number of x, or 1, plus 1. And again, there are 2 rows of that. So then my equation could be, now the constant is just plus 1, and y equals x plus 1, but 2 times. There are 2 rows of x plus 1. So I write 2 times x plus 1 in parentheses plus 1. And then the cool thing is you can discuss how these 2 equations are equivalent but written differently, and this brings in the distributive property in a natural way so kids can understand why x plus 1 twice is 2x. Well, it's 2x plus 2, but then you add 1 to it, where here you already have the 3 total. So I hope this helps. Whether you're a teacher or a student, let me know if you have any questions. I appreciate your time. Have a great day.